My name is David Jonas, and as chair of the chemistry department, I welcome you to the University of Colorado at Boulder's 2020 Department of Chemistry Virtual Commencement Recognition Ceremony. Today, we recognize the achievements of our graduates, along with their families and friends who have helped them along the way. Before our ceremony starts, I would like to recognize the parents of our graduates. Raising a CU graduate is a significant accomplishment. We are all grateful to you and share in your pride in your graduate today. Earning a degree in chemistry requires intelligence, hard work, and persistence, but it is worthwhile. The chemistry graduates we are honoring today are joining a distinguished group. CU chemistry graduates and faculty have found that volatile organic compounds from personal care products now exceed those from motor vehicles in American cities, fabricated the world's smallest 3D transistor, developed the red phosphors in LED displays and lighting, invented the adhesive in Post-it notes and co-invented Post-it notes after persistently searching for an application, and helped prevent nuclear war by convincingly predicting that a fully successful preemptive nuclear strike would devastate the winter during the nuclear winter that followed. Given the accomplishments of our graduates, it is no wonder that the CU chemistry program is recognized as one of our nation's best. This recognition for a relatively small program is possible because the University of Colorado is a special place and it attracts special people. This spring, our faculty managed to start remote teaching on only 2 days' notice, and our students rose to the challenge of remote learning in difficult circumstances. Today, we celebrate them as graduates. Our graduates are now certified to the world as scientists. Among scientists, chemists are a breed apart. Last year, psychology and design researchers developed a new font to aid learning. They called it Sans Forgetica, bastard Latin for without forgetting. After carefully controlled studies, they found that it helped comprehension in every subject except chemistry. The thesis titles you will hear today are in a language that Donald Duck's nephews, Huey, Dewey, and Louie, once referred to in a cartoon as chemical talk. For every student who has completed a thesis, their faculty, advisor, and mentor will provide a translation of the thesis title to help the rest of us understand what the thesis is about. As you will hear, chemists are poised to address unique challenges for our world. Today, I want to encourage all of our graduates to contribute to society in ways that use their unique aspirations, skills, and abilities. Before we recognize our graduates, I would like to recognize the dedicated departmental staff who have helped them along the way. In particular, Ann McWilliams has helped our undergraduates. Matt Bone helped our graduate students and organized today's ceremony. Director of Advanced Laboratories, Dr. Molly Larson, will tell you about what our undergraduates have accomplished this year. And Director of Organic Chemistry Laboratories, Dr. Jackie Richardson, will serve as our commencement marshal. Now it is time to recognize our graduating students.
Samantha's thesis research was on the physical chemistry of fluorescent proteins, which are very widely used genetically encoded labels used in cell biology and for investigating the molecular basis of disease. One of the frontiers in biophysics research is to develop microscopy techniques that enable high spatial resolution imaging in live cells down to the single molecule level. Fluorescent proteins that emit light in the far red or near infrared would be very advantageous for several types of cutting-edge cellular imaging. Samantha performed key experiments designed to understand the various processes that occur in these proteins after they absorb light. She investigated a process called dark state conversion, which causes single molecules to blink on and off and is used to spatially localize them. Her work centered on two near-infrared fluorescent proteins called SMRF-P and MRF-P670. This research required significant innovations in the design and fabrication of microwell devices for confining protein samples to be interrogated by laser spectroscopy. The microwell devices she designed were used to perform time-resolved fluorescence measurements, which identified the timescales of photophysics which lead to blinking. She also performed quantitative modeling of the fluorescence data, which led to an improved understanding of the differences between the two proteins, and which will be used to guide next generations of fluorescent protein development. In addition to her outstanding laboratory work, Samantha was an active participant in CU's molecular biophysics training program, a mentor for my undergraduate students, and an effective force for excellent social dynamics within my research program. She has a bright future in front of her. Congratulations, Samantha.
Hello, Zach. It really gives me immense pleasure to talk to you today on behalf of your PhD. Zachary Feinrex defended his PhD thesis on March 10, just days before the University of Colorado lockdown. The title of his thesis was Measurements of the Emissions and Reactions of Anthropogenic and Biomass Burning VOCs. Zach defended his thesis in front of his girlfriend, Skylar, his parents, and many of his family and friends. Many of these had come from Toronto, where Zach is from. So Zach's PhD research was co-advised by Professor Paul Zeman and myself. With Paul, Zach worked on chamber studies of two benzene diols that are common in biomass burning. And with me, Zach worked on an indoor air chemistry study at the Delward Athletic Center on the campus of CU Boulder. Zach found a lot of VOCs that had something to do with sweat. He saw VOCs from sweaty people and from the deodorants that they use to cover up their sweat. And he also saw VOCs that are formed from chemical reactions of chlorine-based cleaners with sweat. Zach, like I said, I'm really very happy that you've reached this milestone. It's been a long and winding road since we first met in 2014. I wish you all the best for the future. In June, you'll start as a postdoc with NOAA, just down the road. And you should know that you're always welcome to come visit and maybe collaborate. So all the best for the future, Zach.
It's really my great pleasure to introduce Michael Ortiz's research of complements. Michael's thesis research includes the design and synthesis of covalent organic polyhedrons, or commonly known as cage molecules. These well-defined closed organic nanostructures consist of various photoresponsive chromophores, such as porphyrins, phosphatosanins, trexins, just to name a few. And they have found wide applicability in the fields of host gas chemistry, chemical sensing, catalysis, and notably as model systems for optoelectronic organic materials. Conventionally, organic molded cages were prepared in stepwise fashion, which is very time-consuming and provides very low use. Michael's PhD research centers around the use of reversible alkyne metathesis reaction to selectively construct molded cage architectures in one step in high yield. He has spent time on the alkyne metathesis catalyst synthesis and applied them to various novel cage design, preparation, and property study. Besides Michael's synthetic efforts, he has committed several of these novel cage compounds to detailed spectroscopic analysis. steady state and time result spectroscopies have been employed to better understand the structure property relationships and excited state dynamics of these new nanosized cage molecules. These insights open new possibilities for addressing fundamental challenges faced by integrating organic materials into optoelectronic devices. Michael has been a really good team player, and I sincerely wish him great success in his future career. Good luck, Michael.
Hi all, my name's Michael Ortiz. I want to thank a few people today that are responsible for helping me through this PhD process. I want to thank my PI, Dr. Wei Zhang, and his wife, Alice, all the members of the current Zhang group, and past members, Ryan McCaffrey, Kenji Okochi. Thank you all for the time you've invested in me, in my research, in my education. I want to thank Jae-Hong Park and Xia Yang, who worked directly with me throughout my PhD, and they helped expand my perspective and just the patience they offered throughout the whole learning process. I really appreciate it. My classmates, including Kevin Dorney, James Smith, without friends like y'all, I don't know how I would have made it through all this. To my family, Mom, Dad, and Alyssa, for your unwavering love and support day to day, year to year. Thank you all for believing in me. And finally, to my wife, Becca, you've been with me since the beginning, through all the hard times. Thank you for never giving up on me. And I'm excited for the next chapter in our lives together. So I love you all, and thank you for being part of this journey with me.
Hi, my name is Gordana Dukovic, and I'm the PhD advisor of Christina Vrouwenwelder. Christina's dissertation title is The Impact of Ligand Passivation on Charge Transfer, Trapping, and Diffusion in Photoexcited Cadmium Sulfide Nanocrystals. Christina's research focused on very small particles of a semiconductor called cadmium sulfide. These particles are only about 1/1000th of a meter in diameter. And Christina studies what happens when one modifies the surface of these semiconductor particles and how this changes what happens after they absorb light. Christina found that when the surfaces of these particles are modified in a very specific way, they produced hydrogen under illumination with light. This is important because hydrogen is a fuel. And if we can make hydrogen using light, we can make solar fuels to someday perhaps replace fossil fuels. In her dissertation, Christina describes what specifically about this surface modification makes the hydrogen production possible. In addition to her research during her time at CU, Christina has blossomed as a science writer. She has written for a local science blog called CU Science Buffs, and she has also written for a national blog called ChemBites. And her writing has also appeared in the blog of the Scientific American. And more recently, Christina is a co-founder and editor-in-chief of a blog called GeoBites. Please join me in congratulating Christina on her accomplishments and the completion of her PhD. Thank you.
Hi, my name is Molly Larson, and I am the Undergraduate Advanced Lab Director in the Chemistry Department here at CU Boulder. I manage the lab classes your graduate took their final 2 years while earning their degree here at CU. I wanted to say a few words to the 2020 Chemistry Department graduating class. I wish we could be doing this in person, and I wish we could be properly celebrating the amazing accomplishments of the graduates we honor today. I am so proud of the hard work and success of all the graduates here. I would like to use this opportunity to both celebrate our graduates and to let the friends and families of this graduating class know what an amazing group of students this is, and to give you a glimpse of what your graduate did while here at CU. We did some pretty fun stuff in the chemistry labs. Many of the students in this group have made and tested a superconductor. Several of them made and detonated an explosive. They all use light to figure out properties of molecules, such as how long their bonds are and how fast the atoms in them vibrate. There are some people in this audience who helped develop an undergraduate teaching experiment for building lithium-ion batteries, and other graduates in this group who tested this experiment as students for the first time. And they worked. Every graduate in this audience also developed their own experiment and performed it in an attempt to apply their chemistry skills to discover something about the world that was previously unknown. For many of the students in this audience, their ability to perform this experiment was cut short by the requirement that their courses be moved offline. But these students all put in extra effort in amazing ways in the last week we were allowed in the lab. The students graduating today worked hard to accomplish what they did. They did not just get a degree, they came to get an education. The students in this group came to class ready to learn and then went home and worked hard on the material to get the most out of their time here. And I am so proud of their efforts. But more than that, this is a nice group of students. This is a group of students who accept members of their community who are different and who respect others even when they do not agree with them. I had many opportunities to overhear these students in my labs. And yes, I was listening. And what I heard was students listening to each other, respecting each other, and helping each other. I once overheard a student telling his classmates, "I'm so mad about this lab grade, but I need to calm down enough about it so that I can discuss it with my TA and still be respectful to him." At least one student in this group came to lab the day after his 21st birthday, not feeling fabulous, but prepared to do his experiment with the rest of his group. There are students in this class who did graduate level research while they were here, who are going to go on to do amazing things using the tools they obtained from their classes and research. I think all the graduates in this class have the potential to go on and do something great. I know they will use the skills we taught them here at CU. The world is going to need good scientists to combat some of the challenges in the horizon. We need honest scientists, one who analyze the data they have, not the data they want, who think well about their observations and who are able to synthesize their knowledge in a way to make their observations useful. I hope your experience here at CU gave you some of these tools. I know not everyone in this class plans to go on to do science, but I hope you will all use what you have learned in your classes in whatever career or life path you choose. I hope we taught you how to think about your observations, how to think about the physical world, and how to approach a problem, how to turn it in your head in different ways and unravel it until you're able to find a solution. Also, I hope that you remember that whenever you're in a chemistry lab, you need to wear your goggles. I would love to congratulate you in person and just see where you all end up. If you ever find yourself on CU's campus when the world opens up again, please come up to my labs and say hi. I hope you get a chance to really celebrate this accomplishment we applaud today, because you all did an excellent job and you have all earned a celebration. Congratulations to all of you. I'm so proud.
Hey everybody, my name is Spencer Bajkar and I'm graduating with a BA in Chemistry and Sociology, a certificate in Green Chemistry and Chemical Stewardship from the University of Washington. I want to give a huge thank you to all my friends and family for being so incredibly supportive throughout all the years, especially to my Golden Buffalo Marching Band family who has been phenomenal throughout all the years. I also want to give a huge shout out to my brothers in Kappa Kappa Psi for always trusting in me and giving me such an incredible support network whenever I needed to fall on them. Additionally, I wanted to give a huge thank you to the CU Green Labs and the Environmental Center, especially Kathy and Batul, and all the grad students that were involved in the Chem Unity Scholarship for granting me the opportunity to do the Green Chemistry Certificate Program. Thank you all so much, and congratulations to all my fellow graduates. Go Buff!
I'd like to thank my friends and family who provided me with the support and love that I needed to get to this point. Lily, Niru, Yesha, Elliot, Blake, Enrique, Justin, Quentin, thank you. You guys made all of the ups and downs of the past 4 years worth it. I'd also like to thank the professors and the graduate students for all of the courses I've taken over these past 4 years, as well as the professors I had the opportunity to work with as a learning assistant and a TA. But I'd especially like to thank the professors who made the major course options possible for myself and my cohort. It was an incredible experience and one I won't ever forget. Lastly, I'd like to thank Dr. Walczak and the Walczak Lab for providing me with a learning environment and a community that allowed me to develop hands-on skills and consider my options for my future. This department provided me with the community and family I needed to succeed. Thank you.
I just wanted to thank all the professors who have helped me throughout my college chemistry career. These include Dr. Amy Palmer, Dr. Tarek Samakia, Dr. Machi Walczak, Dr. Jackie Richardson, Dr. Ellie Brown, Dr. Robert Parson, Dr. Sandeep Sharma, Dr. Niels Damrauer, Dr. Rainer Volkamer, Dr. Joost de Gauw, Dr. Jihei Park, and Dr. Molly Larson. I especially wanted to thank Molly for all the help that she has provided in the last 2 years in PChem lab and inorganic lab and analytical lab. And then also Tarek. I'm sorry I fell asleep in your class freshman year, but I'm very thankful that you allowed me to work in your lab for the past year and a half now. And so thank you all.
Thank you to the chemistry department at CU Boulder for making my years here awesome and memorable. And thank you to Molly Larson for getting me through all those difficult labs. And I also just wanted to thank my friends and my family for always being there for me and for supporting me through my degrees. I've had an awesome time at CU Boulder and I will miss you all.
Hi, I just want to say thank you to all the faculty at the University of Colorado Boulder for supporting me in the past 4 years to obtain my chemistry degree. I have been able to grow in so many different ways that I didn't even think were possible, while also obtaining some of the most amazing people in my life. I definitely have some lifelong friends that will be there with me through thick and thin, and I have made some great relationships with some faculty members that I know will support me in my future and any career path that I choose. So thank you so much again to everyone at the University of Colorado Boulder for making my college experience truly amazing.
Hello, my name is Matthias Weber, and I have had the pleasure of being Kenneth Wilson's research advisor over the last 2 years. Let me tell you briefly about Kenneth's research. Kenneth's thesis deals with a material called perovskite, which shows great promise for a whole area of technological applications, from new and brighter displays to solar cells. Charged iodine or bromine atoms form a part of this material's crystal structure, which you can see behind me in the background. The bromine and iodine atoms would be the red dots here. The material can be made with only one sort of these two atoms or with a mixture of both, and the mixing ratio can be used to control which color of light the material can absorb or emit. Curiously, exposure to light of certain wavelengths makes these atoms migrate through the crystal, and the material will unmix, forming regions that are rich in iodine. This effect falls into a very interesting class of behavior called active matter, which is a fascinating subject in physics and chemistry. However, in this particular case, it is not desirable for technology applications of perovskites. For both of these reasons, it is necessary to understand the effect in detail. Kenneth put his material under high pressure up to about 3,000 atmospheres and measured the speed of unmixing at different pressures. These results help us understand what allows the transport of the atoms involved in the unmixing process. Well, Kenneth did a fantastic job as a researcher, and he will continue to do research as he will leave Boulder this summer to go to Madison, Wisconsin for graduate school. We will miss you greatly here in the research team, and I wish you the best of luck and success for your career. Well done, Kenny.
Hey everyone, thanks for watching. I just wanted to say thank you to all the people in my life that have supported and inspired me throughout my time at CU. Whether you were directly involved with the campus or not, you've helped make my college experience extremely transformative and rewarding. To the many teachers I've had over the years, thank you for all your enthusiasm and your very hard work. As an educator, you have your work cut out for you, and I deeply admire what you do. Specifically, I want to thank Molly Larson, the Upper Division Lab Coordinator, Matthias Weber, my awesome undergraduate research advisor, and Diana Brostel, my high school chemistry teacher. Your contagious love of chemistry is a big reason I decided to study it at CU, and why I'm so excited to continue to do so in graduate school. To my friends, family, classmates, and coworkers, I cannot thank you enough. Your unwavering support has been humbling, and it has made me a more empathetic and sensitive person. In particular, I want to thank my fun and supportive lab mates, all my choir friends, climbing buddies, my loving and supportive parents, my sister Abby, my girlfriend Erica, and my friend and roommate Elliot. You're all incredible people, and I'm so lucky to be surrounded by all of you. Thanks again. Bye.
Hi, I'm Nan Zhang. I'm graduating in Bachelor of Chemistry. I'd like to say special thanks to my parents. It's also very nice to meet all my friends here, especially P-Stock. Please stay safe.
Now, it is my pleasure to announce the winners of Departmental Awards for graduating seniors. Recipients are asked to email Director of Undergraduate Academic Affairs, Ann McWilliams, with your mailing address by May 20th. The American Chemical Society, or ACS, makes awards in 4 areas of chemistry. The American Chemical Society Honorary Award in Analytical Chemistry is given in recognition of outstanding achievement in analytical chemistry. The award consists of a certificate, a medallion, and a 1-year membership in the ACS Division of Analytical Chemistry. Our 2020 award goes to Quentin Brown. The American Chemical Society Honorary Award in Inorganic Chemistry is given in recognition of outstanding achievement in inorganic chemistry. The award is a letter of commendation. Our 2019 award went to December 2019 graduate Sebastian Krajewski, and our 2020 award will go to Zachary Mast, who anticipates a December 2020 graduation. The American Chemical Society Honorary Award in Organic Chemistry recognizes seniors who have displayed significant aptitude for organic chemistry in both formal coursework and research accomplishments. The award consists of a letter of recognition, a certificate, and affiliate membership in the ACS Division of Organic Chemistry. Our 2020 award goes to Dominique Blackman. The American Chemical Society Honorary Award in Physical Chemistry is given in recognition of scholastic achievement and a significant aptitude for physical chemistry. The award consists of a certificate and a 1-year membership in the ACS Division of Physical Chemistry. Our 2020 award goes to Anastasia Jeffrey. The American Institute of Chemists Award is given in recognition of scholastic achievement, leadership, and professional promise. The award consists of a certificate, a student affiliate membership in the American Institute of Chemists, and an online subscription to The Chemist, a peer-reviewed journal. Our 2020 award goes to Alexandra Collard. The Merck Index Award is given by the Royal Society of Chemistry in London in recognition of scholastic excellence in chemical science and research. The award consists of a certificate and a copy of the Merck Index, which is where chemists get information about chemicals that is more trustworthy than the safety data sheets used in the US. Our 2020 award goes to Kenneth Wilson. Finally, Sebastian Krajewski and his faculty mentor, Mike Marshak, have won the National 2019 ACS Division of Inorganic Chemistry Award for undergraduate research. The winner of this national award was selected from seniors nominated by universities from all across the USA. The award comes with an expenses-paid invitation to give a talk at the Fall ACS meeting in San Francisco, where Sebastian and Mike will be guests of honor at an ACS dinner. The award consists of a plaque and a $1,000 prize to Sebastian. Please join me in congratulating all of our award-winning graduates. On behalf of the Department of Chemistry, we wish we could congratulate all of our graduates, their friends, and their families properly in person. We hope all of you will be able to join us on the beautiful CU Boulder campus for our Spring 2021 commencement, at which we will include all of our 2020 graduates who are able to attend. And now, we will conclude our commencement recognition ceremony with the Norlin Charge, first given to CU graduates by CU President George Norlin in 1935.
Before I read the charge, I'd like to describe Norlin's achievements in a little more detail. Dr. George Norlin served as the president of CU from 1919 to 1939. Probably the most beloved and admired of CU presidents, he oversaw the implementation of Charles Clowder's iconic architectural designs for the campus, watched the student population triple to 4,500 students, and completed a $4 million building program despite the difficulties of the Great Depression. But it was Norlin's dedication to humanity that established his greatest legacy. In 1922, the Ku Klux Klan took control of the Colorado legislature. They demanded Norlin fire all Catholic and Jewish faculty in return for continued funding from the state of Colorado. He refused, saying, "We can perhaps afford to play politics with many things, but not with education." The university survived 4 years on a shoestring budget, until the Klan lost control of the legislature and governorship in 1926. Norlin's commitment to the betterment of the people who comprised CU helped contribute to the long-term successes of the university today. In keeping with tradition, we conclude our program with an excerpt from the Norlin Charge. You are now certified to the world at large as alumni of the university. Commencement does not mean, as many wrongly think, the breaking of ties and the beginning of life apart. Rather, it marks your initiation in the fullest sense into the fellowship of the university, as bearers of her torch, as centers of her influence, as promoters of her spirit. The university is not the campus, not the buildings on the campus, not the faculties, not the students of any one time, not one of these or all of them. The university consists of all who come into and go forth from her halls, who are touched by her influence and who carry on her spirit. We welcome you into the fellowship. We bid you farewell, only in the sense that we pray you may fare well. You go forth, but not from us. We remain, but not severed from you. On behalf of all the faculty and staff of our department and the university, congratulations on your outstanding accomplishments, and best wishes for all that you undertake. May you all fare well. Thank you for being with us today. This concludes the Chemistry Department's recognition ceremony for the Spring 2020 commencement.